Hello everyone. So today we're gonna learn how to solve compound inequalities. Compound inequalities. The previous video I showed you how to solve linear inequalities, but this is a different this is a different sort of inequality. It's called compound inequalities, and today we're gonna learn how to solve it. So, but in order to do that, so what I mean by compound inequalities, so let's write an example here so you know what I'm talking about. So let's say we have 2x minus 4 greater or equal than 2, less or equal than 4. So this is a compound inequality. But before, in the previous video, we learned how to solve linear inequalities like 2x minus 4 less or equal than 2. So as you can see here the difference, so you can see the difference. So this is composed, this is a inequality composed together. This is two inequality composed together. But this, we learned how to solve this, but we did not learn how to solve this compound inequality. So, and today that's what we're gonna learn. But in order to do that, we have to first introduce a concept of sets. Concept of sets and the union and intersection of sets. So so a set, let's give an example of a set. So let's say, so we have a set, set A, and this set A has, this is the this is how we denote a set. So A equals, let's say we have this set and it has these numbers 1 2 4 6. A set could also be, and 1 2 and 4 called members of this set. A set can also be members, can also be anything, can also be like alphabets, like let's say A is the set of let's give an example, like some a concrete example. Let's say we have a set that has a set of colors, like a set of colors. Let's see, we have green, blue, yellow. So green, blue, and yellow are members of the set A. So members could be literally anything, but in our case we're just gonna focus on numbers. Just gonna focus on sets that has numbers, like A has 2 6 7 8, and then B has some other numbers like 4 5 8, whatever. Okay, so but members of a set could be literally anything. Okay, could be literally anything. Okay, so, and the goal here is to understand what the union and the intersection of sets are. What is the union and what is the intersection? So here I have a couple definitions for you. So the union of let's choose a different color. So the union of a set A and B, denoted A union B. So this is how we denote union. A union B is the set of elements, that belongs to, just focus here, focus on belongs to set A or B. This is the key here, or E or B, or to both the sets A and B. So in order to understand this, let's give an example. Let's say we have the set, change the color. Let's see, we have the set, let's say we have this set A that has 2 8 9 5 11, and let's say we have another set B that has 22 2 8 5 7. So what is the A union B? Okay, let's choose a different color. So what is A union B? So A union B, so this is how we denote A union B. So right here, A union B equals, according to the definition, the union of a set A and B, denoted A union B, is the set, is also a set, A union B is also a set of elements that belongs to set A or B, belongs to set A or B. It means if an element belongs to A, it is in A union B. If an element belongs to B, is an that element is also in A union B. So what would be E union B in this case? So it would be 2. So 2 is an element of A, then it must be also an element of E union B. 8 is the same. 9 also has to be. 5 has to be, is an element of A, so it has to be in on A union B. 11, and we said or, it means or B. That means element, if an element is in B, then is also in A union B. So 22, as you can see here, is in B. That means it must be also in A union B. 2 is in B. That means it has to be in A union B. But remember here, we do not repeat. Since we already have 2, we do not repeat that 2 because we already have it. So 2 is in A union B. 8 also is, we already have 8, so we do not repeat that number. And then 5 is also in A union B, so we do not repeat that because it's already here. 8 and 2 and 8 and 5 already there, so we do not repeat the numbers. And 7 is also, 7 is an element of B, then it must be an element of A union B, so we'll write 7. So as you can see here, A union B is all the elements of A and all the elements of B, such that we do not repeat the same element, we do not repeat the same element. Okay, and that's what it said here. It said is the set of element that belongs to set A or B or to both sets E and B, to both sets E and B. It could also be in A and B, like for 2 and 8 and 5, 2, 8 and 5. They're all elements of E, and they're all element of B. So E union B is all the elements of E and B, or B and A and B, or both can be in A and B. So that's what the union of A, that's what the union is, the definition in this particular example. So let's give an example of a intersection. So let's say we have A equals 1, 2, 3, 4, and let's say we have B. Let's see, B is 2, 3, 11, 12. Okay, so let's see what would be this A intersection B. A intersection B. So this is how we denote A, and it's like a U concave to concave down. A union B equals, so the intersection, it said the intersection of two sets A and B, denoted A intersection B, is the set of elements common, this is the key word here, common to A and B, common to A and B, common to A and B, common to A and B. That means we're only taking elements, that means this set, because it's also a set, this set A intersection B is have only elements that are common to A and B. So that means if we want to put an element here in this set, it has to be in A and it has to be in B, and those are the only element that we choose. So one is in A But if we go to the to B is not in B, so that means we can A. That means doesn't 1 does not belong to intersection A union B. What about 2? So we have 2, an element of A. 2 is also an element of B. We could also say a member. We could also use a member, either an element or a member. Let's say 2 is an element of A, 2 is an element of B. That means 2 is in the intersection. 3 is an element of A, and it's also an element of B. That means it's an element of the intersection. Is 4 an element of A? Yes, but it's not an element of B. That means we do not include it in A intersection B. 11 is an element of B, but is not an element of A. Okay, 12, just do this. 12 is an element of B, but is not an A. So that means we do not include it in A intersection B. So A intersection B would be just 2 and 3. Those are the 2 elements that are in A and in B, and that's what it's called. That's what the A intersection B is in this particular example. But let's give you a more a visual, I would say a visual representation of the union and the intersection, so you can understand it more. So let's say this is my set. Let's say this is my set A, and let's say this is my set B. So, and let's do the same thing again here. So let's say this is my set A, and this is my set B. All right. So what would be the E union B? E union B. If we go back to the definition, it said all the elements of A and all the elements of B. So that means all the elements. So all the elements of A and all the elements of B, such that we do not repeat the same elements. Okay, so this is a visual representation of A union B. So all the elements, I'm talking about all the elements inside A and all the element inside B. Okay, so A union B. So this shaded region would be A union B. The shaded region would be A according to the definition. And what about the intersection? So let's say A intersection B. So what would be according to the definition? It said the intersection of two sets A and B denoted A is the set of elements common to A and B. Only elements that are common to A and B. So that what would be that region? What would be so all those elements? Where do you think those elements would be in this diagram? So those elements would be here, because this is the only region that is common to A and B. So if you remember the example we did, we had 2 and 3. So 2 and 3 would be here. 2 and 3 those 2 elements would be here. They would belong to B and would belong to E. So all these elements that are here in this region are the elements of A intersection B. And this is actually called the Venn diagram. This visualization of union and intersection is called the Venn diagram. Okay, so this is like a visual representation of A intersection B. So let's give another example so you can more understand. So let's say we have this. We could name the sets any alphabets. Well, we could just stick with A. So just say we have a more example, like an earlier example that the example that I have earlier, if you remember, we have a set of colors. Let's say we have green. Let's say my set A has a set of colors, and one of them is green, the other one is blue, the other one is yellow, and we have a set B, and this set B has elements, let's say brown, green, black, and black. All right, so let's see. So what would be A union B in this case? So what would be A union B would be A union. If you remember, we said all the elements that belong to A and B. So this element would be green because it's an element of A. We don't care if it's an element of B, as long as it's in A, that means it belongs to the union. Green, we have blue because it's an element of A. Again, we don't care if it's an element of B because it's in A. And we have yellow, the same thing goes for yellow. And if we go back to A, the same thing goes for brown. So we have brown as well. It's in B, but we do not care if it's in A, as long as it's in B, as long as it's one of these. As long as it's one of these, then it has to belong to the intersection. I mean to the union. Brown, the same thing goes for green, but we do not repeat the same because we already have green. We do not repeat it because it's already here. And we have black. All right. Black is an element of B, so it's also an element of the union. What about E intersection B? E intersection B would be, let's choose different color here. Let's choose different color. So it would be A intersection B. A intersection B would be only common elements. If you remember from definition, we said common elements. So green is there a common element here? Yes, it is in A, and it is in B. So that means green belongs to what about blue? Blue is an element of A, but it's not in B, so it's not common, so we do not include it in A intersection B. What about yellow? Yellow is in A, but it's not in B, that means we do not include it. Brown is in B, but it's not in A, so we do not include it. Green is a common element, but we already have it here, so we do not repeat it. Black is an element of B, but it's not an A. So the only element that is in A intersection B is green. So this is A intersection B, and that's how do you find the A and B. All right, so and this would help us. So in the second video, I'm gonna explain how this intersection and the union relates to compound inequalities. So to just motivate, the second video, I would write an example here of compound inequalities. So let's say 2x minus 4 is less or equal than 5 and 11. So we're gonna learn how we're gonna solve this kind of inequalities. It's called compound inequalities. And this intersection and the union will help us understand the solution of this compound inequalities. And I'll see you in the next video.